Hi and welcome to my tutorial. My name is Dennis and I am the author of MapMagick tool. In this video I'd like to show you one of the MapMagick use cases, a creation of the vast semi-procedural island of hundreds of square kilometers in size. Semi-procedural means that we will specify the main island shape and detail some key locations, and everything else will be done automatically. Prepare for a long, in-depth and comprehensive tutorial. It will be the whole lecture devoted to all of the main MapMagick aspects. I will start from scratch and end up with an accomplished and playable scene, talking about all generators I use and demonstrating how they could be applied. So, if you will be patient enough to watch the video entirely, you can issue yourself a certificate of the confident MapMagick user. Going forward, I'd like to show some of the results that will be achieved to the end of this tutorial. You can see them in a splash screen now. I will try to describe each step in detail, but if you are not familiar with the MapMagick, you'd better watch some of my other tutorials. You can see their links in an annotation now or in video description. Here is the short description of what I'm going to do. The island will consist of 100 terrains, placed in a grid with a side of 10 terrains. Each terrain size is 1 square kilometer. The island will use a height map that I will draw. This height map will not be very detailed. It will be just a base for the further processing. It just needed to give an island an initial form. All of the details will be procedural. The height map will spread at all of the 100 terrain grid, and each of the terrains will know what part of the height map should be used automatically. There's no need to split the height map. The center of the coordinates will lay somewhere in the center of an island, so the height map will be offset at -5 kilometers at both axes. I will not work with all the 100 terrains. The maximum number of the terrains will be 20, just to realize the size of the island and the proper height needed. And once I'm happy with these settings, I will leave just 4 terrains. Then I will add some relief to the abstract and smooth height map using the procedural generators. Then the terrain will be textured, and then an objects like stones and trees and grass will be placed on it. And then I will add 3 villages to the island. I will do a manual level editing, taking the generated terrains as a source and changing them in the way I want. Now let's get down to business. We'll start with an empty scene. Then create a MapMagick object from a Game Object menu, 3D object, MapMagick. This will create a first pin terrain and the initial noise and curve graph. I'll open the editor window and dock it here. We will not need noise or curve now, so I will remove those 2 generators. What we will really need is a raw input. I will create raw input generator and connect it to the height output. Now I should assign a raw image here, but to do so I need to create it first. Note that the image should be 16-bit grayscale. So I'll switch to the image editor and create a new document. It shouldn't be too big, I guess 256 will be okay. I'll set the grayscale and 16-bit and press OK. I will fill background with black, and then I'll paint some of the haze with a low opacity brush. The image doesn't have to be beautiful or precise, it is just the base for our further processing. When the painting is done, I will save a file, anywhere. It doesn't have to be in the assets folder. Note that I'm using PC byte order. And then I'll open the file in the raw generator. Here you can see the resulting height map. Let me say a couple of words about the way the raw input works. For clarity, I will pin some of the neighbor terrains. The intensity parameter is a multiplier that adjusts the final height value. By the default, the height map is stretched to 1 terrain only, but it could be changed with a scale parameter. Changing it, you can set the size of a height map bigger or smaller than 1 terrain. And with the offset, it is possible to move the height map position on X or z-axis. The negative values work too. The tile parameter can make the height map repeat endlessly. So I'd rather reset all the parameters, reload the height map, and unpin all the unnecessary terrains. But for now we've got only one terrain with a 1 square kilometer in size, and we want our island to be bigger. I was talking about 100 square kilometers, which means that we should have a grid of such terrains with a side of 10. So I will add some of the terrains just to show how big our island should be. I will do this using terrain spin, but I will not pin all of the 100 terrains. It will be too much. I'll just pin 1 or 2 rows. Something like this. 5 and 10. There are just 20 terrains, but keep in mind that it's just a slice of our island. Its real size is much bigger. Now let's scale our island to make it fill all of the planned area. Since it should be scaled 10 times, we will set the scale in row input to 10. And since the center of the terrain should be placed at the 0 coordinate, we will make an offset of -5 kilometers on both axes. Let's wait a bit while it will process all of the 20 terrains. It will take a time because an area we selected is actually very big. It will take about an hour for the player to run from the one end of the slice to the other. We will not work with all of the slice and just pin 2 or 4 terrains for the further work. The generate will be complete when this mark will change to green. But finally all we can see is almost a plain land. If we will take a closer look, we will note some bumpiness, but it is far from the island that was planned. This is happening because the heatmap was stretched to all of the terrain, scaling in X and Z axis, but the height wasn't changed. So now we've got to increase the maximum height. I will not scale it 10 times, this will make our island too steep, but I'll scale it in 4 times. And again it will take some time to calculate. And while the terrains are generating, I will add a water level. I'm using Aqua's free asset to create water and I'm absolutely happy with it so far. It's really an amazing asset. I'll place a prepared plane in the center of the scene and scale it so it fills all the area. Note that this approach is too primitive. In your game you will have to hide water where it lays below the terrain level to save performance, but in this case it will be okay. We will not work with all the 20 terrains further, so I will unpin all of the terrains except these 2. And I've got a small island on a heat map near the big one. Probably it will be the noob location or something. It seems to be located somewhere around here. So I will pin a couple of the terrains from it too. I will add some terraces to make the surfaces of the island a bit more planar. And I'll make these terraces very smooth by lowering the steepness value. I will talk about the terrace generator in detail a bit later. Now I will disable the water and disconnect the heat output, because now we are going to create a detailization map that will be blended with the heat map we created. Renault intensity parameter determines how visible a Renault generator will be. With an intensity of 0 it will not affect the heat in any way. With the type value you can select one of the Renault patterns. Cell count sets the size of the Renault pattern. Note that the cell count should be equal to the power of 2. With the lowering of the cell count, the intensity value should be lowered too. Uniformity sets how similar all of the cells would be. Now I will reset the Voronoi generator and I will increase its pattern. I will create sequential Voronoi generators that will start from this one. The first one will have the cellular algorithm and the biggest detail. The others are organic and have a high detail value. Each generator is applied additively. And then I'll adjust the generator's chains with the curve. I will add a curve as a last generator. Use one of the presets to define curve shape quickly, and adding the key could be done with a right mouse. You can see that we have a sort of local mountains. Now we'll blend the detail map with the original island using the blend generator. I will apply the detail map additive, so we should set add in blend type. And then we will connect the blend inputs with our maps and blend output with the heat output generator. You can see that we've got the same island, but a bit more detailed. But our terrain looks too polished and unrealistic yet. So I'm going to add some noise. I'll insert a noise generator between the blend and heat output generators. I'll lower noise size a bit and noise amount greatly to achieve something like this. Let me disconnect the noise to show you how it works. The noise intensity parameter sets the overall noise amount. And the size, the number of fractals. The bigger the size, the more diverse and unpredictable the noise is. The detail parameter sets the fractal influence bias, and this results in a more smooth or more noisy noise. We can move the noise using the offset parameter. But let's return to our island. Our next generator will be a terrace. We were already using the terrace generator, but let's take a closer look at it. A thread number sets the number of the terrace steps. When the value is too high, a step is almost invisible. Uniformity defines how even the terrace height will be. Note that at the low values, huge steps can coexist with the tiny ones. Stepness, as you already may notice, sets how inclined and smooth the terrace walls will be. I think that these terrace values should be okay. And now let's proceed to the generator that will make our terrain really scenic. It's an erosion. This generator is the most resource-intensive generator, so you will have to wait a bit while it is processing. Erosion is an iterative generator. Each iteration the land is eroded a bit, so changing the iterations count can set the erosion amount as well as the generation time. Durability is the factor that determines how much the land is affected by erosion. A sediment factor. When it is set to 1, all of the sediment raised by erosion returns back to the terrain, so that the landmass doesn't change. If the factor is set to 0.5, only the half of the sediment is returned. Fluidity iterations determine how far the sediment will travel from the place where it was raised. Increasing this parameter slows down an erosion generator. Now I'd like to switch to the small island to see what erosion is done with it. The ruffle parameter determines how uneven the land reacts to the temperature erosion. Lower value results in a more smooth but repeating look of the slopes, and increasing the value brings some noise to them. The opacity parameter defines how visible will be the cliff or the sediment maps. I will talk about the opacity parameter a bit later, when we will start texturing our island. Let's take a look at what we've got, and maybe we will tune something a bit. Personally, I think that the terrain is very uneven, so I plan to reduce the Voronoi cliff heights. But it's hard to say for sure. So I'm going to run it with a character. I will take a character from the MapMagick demo scene. First I save the current scene and then open up the scene with a demo. Here we'll see the two objects. Let me show you the hierarchy menu. A character itself and the main camera. I copy them using the Ctrl+C keys. And then open up an island scene. Remove a local main camera and paste objects with Ctrl+V. I will place a character to be sure that we are starting not at the sea. And then I'll switch to the play mode. Disregard that I'm opening up a game window, I just disabled it for the tutorial. Let me fall down to earth. Well, I can say that the terrain is very inclined, but I think I can make some modifications. I think I'm gonna scale it proportionally by reducing the maximum height. Then I think I'm gonna make a row terrace a bit more noticeable. And maybe I'll reduce some noise. We'll see. So let's start with setting a maximum height. And then we will increase row input steepness. And then we can see that the water level was increased greatly. So let's lower it a bit. And also I'd like to make a terrain a bit less noisy. And make some erosion tuning. I hope that will be okay. We can return to the height tuning after we will add some texturing. Now let's look at our terrain in a play mode. It is still inclined, but seems to be playable. And now let's add some texturing. We will do this using the texture output. It could be found in an output section. Here I will drag and drop our first background texture. It will be a green grass. And then its normal map. Then I can do some other settings. Here you can see that all of our land is filled with a background texture. By the way, this background name could be renamed to something more adequate. A grass, for instance, or pardon my caps lock. Texture output has a multi-layer structure. This frame is devoted to the grass. To add a new texture, simply click at the plus button next to the layers label. Let's call it cliff. You can switch between the layers by clicking at its name. I will assign cliff textures and do some other settings. But as you can see, there's no cliff appeared in the scene. This is because the cliff layer should require map information about an area where it should be applied. For example, I will connect a cliff input to the erosion's cliff output. You can see that the cliff applied at the most eroded areas of an island. You can use an erosion cliff output, but I'm going to show you the other way to add cliffs. First of all, I will use the slope generator for this. This generator will create a map based on the height map incline. Since the slope is using heights, I will connect it to the final height output. Note that I'm connecting it to the height, not the cliff output. You can see that all of the inclined areas were painted with a cliff. We can adjust the incline limit of the generator by changing its steepness value. When the steepness is high, the slope paints only on the most inclined surfaces. When it is set to low, even not as steep areas are filled. The range parameter determines the gradient smoothness between filled and non-filled areas. Now take a look how awful this connection looks. With the growth of the graph, number of such connections will increase. To avoid this, I will use portals. I will create the first input portal and connect it to the height. I will name it height. Then I will create the second portal, change its type to output and connect it to the slope generator. I can select a portal's input from a list. There's only one item yet, it's a height portal. And once selected, you can see that the slope is working again. Portals look like generators, but actually it's just a way to represent a connection. Instead of drawing a line through the whole graph, you can use portals. It is far more convenient and clear. There is the other way to add cliffs. This time I will add stone texture to the bulging areas. I will use a cavity generator for that. I will use a preview to view the cavity effect on the terrain. Clicking on an output and selecting preview on terrain will turn on a preview mode. High map values are colored green, while the low values are red. Here you can see some of the green dots on the convex areas. I will increase the effect by modifying the intensity value. The further effect increase could be done with a spread parameter. It will fill all the pixels adjacent to the convex one in a radius determined by a spread value. Now if I'll switch a preview to the concave, you can see that all of the hollows are filled with green. I'll switch back to convex and do some adjustments. To exit a preview mode, you can right-click anywhere in the graph and press Preview Clear. Now I'll set up a stone texture. It will be a bright cliff, so I will name it accordingly. And then I'll connect it to the cavity output. You can see the bright texture appeared at the ridges of the mountains. I will make it a bit more noticeable. Now I will add some of the erosion sediment as a texture. But I will not add it directly, I will use a portal again to make the texture graph visually independent from the height graph. I'll call this portal sediment and connect it to the sediment output. Then I will create an input portal for the sediment. And add a new texture layer. On connecting it to the portal, you can see that some of the terrain areas were filled with gray. It is the default blank texture. I'm replacing it with a yellow grass. You can see that in some places the grass lays over the cliff texture. This happens because of the layer order. If I will change the order and send sediment down, it will be drawing below the cliff. Actually, I'm not sure which variant looks better, but I will leave cliffs above just because it is theoretically correct. Now I will tidy up the graph a bit. Then comes the moment of truth. I've got to know how a painted terrain looks in game, so I will start a play mode. I think it's too vapid. So I think we need to return some of the noise we have removed previously. And we're gonna adjust the texture tile size. The grass looks too big and the cliffs are too small. I'll start with the texture size and set the grass size to 12. Well, it's better to use a power of 2 here to repeat a texture the whole number of times per terrain. It will make the seams between terrains invisible. But I'm afraid that 8 will be too little while 16 is too big, so I'm using a compromise. And I'll set 24 for the cliffs. And then I'll adjust some noise. Let me find it in the graph first. And then increase it a bit. Or maybe a bit more. Note that since noise is lying rather deep in the graph, it will take some time to recalculate it. Therefore, to recalculate an erosion and recalculate all the texturing. The texture size seems to be okay, but I'm not sure about the noise. Anyways, we can fine-tune all the scene when we got the grass, the trees and other objects. So I'll leave it this way for now. Then there is a thing that I don't really love on this terrain. It is the shoreline. Here the grass just enters the water. It is not realistic and doesn't look very pretty. I will fix it with a generator, specially designed to make a beach. It is called a shore generator. I will connect it before the final height output, and thus a height portal. On the terrain generate you can actually see no change. It is because of the zero water level in the generator. So I will select a water plane and take a look at the water level. It is 208 in 8, so I'll enter this number in a generator. You see? So far the shore generator does nothing special, it just adds a beach and a ridge nearby. I will incline the beach by adjusting the shore generator intensity value, and then submerge it into the water at 1 meter by lowering the water line. The beach turned out to be very small, so I will increase its size. Let's make it paint the beach with the sand. I will use a portal again, and I will call it beach, and then connect it to the send output of the show. Then I will set up the output portal and end a send texture layer. It will be placed between the grass and the cliff. You can see that the beach was created, but it still needs some adjustment. The ridge is too uniform, it always has the same height and the same incline. I would like to say a couple of words about the ridge incline. While the noise texture is not assigned, it is controlled by only one value, the minimum steepness. Increasing this value will make a ridge less inclined. When the noise map is assigned, the ridge will be blended between minimum and maximum values, therefore between 10 and 2. Let me move the shot generator a bit, with all the portals and output. So we'll create a noise map and connect it as a ridge noise input. You can see that the ridge incline became mostly average, it's about 5. Let's make a noise preview to look why it happened. You can see that the noise size is too big, it fills everything with the medial values. So I will make the noise smaller. And then I will increase its contrast. First of all, I will raise its intensity. This really increased the contrast but made everything look green. So I will adjust the bias. Setting the bias to the value of 1 fills almost everything with reds, while the lower bias make everything green. When it is set to 0.5, the amount of red and green is about equal. So with bias of half, the contrast could be adjusted with an intensity slider. Think of it like of a brightness contrast modification in an image editor. I will turn off the preview and I will make some adjustments. I think that the island became too small because of the beach size and the water level. Maybe I should lower the water a bit. This looks like a low tide. And then I will lower the beach level and add some more adjustments. Now the next thing that I don't like in this beach is that it is created everywhere. Even around these cliffs and these. They look good without any beach. So I'm going to create a mask to exclude them from the shot generator. And to prepare the mask I've got to highlight these cliffs on the map. What is so unusual in these cliffs compared to the other grassy areas? It is the cavity and slope used in texture generate. I will repeat these generators here. Unfortunately, there is no copy-paste generator feature. I have plans to implement it, but still have to copy all the values manually. Now we have to combine the results of these two generators. We'll use the blend with an additive type. We already used it before. And let's see what we've got. Great! It is exactly what was needed. All the cliffs are green and all the grassy areas are red. But actually we need the opposite. We need to exclude the cliffs from the mask. so we will use the curve to invert the map. I will use the same linear curve, but it will go the other direction. It will descend from the left to the right. Now let me preview it. It looks fine. Now I will connect this map as a show mask and disable a preview. You can see that all the cliffy areas were masked out because they were red at the mask and are skipped by the show generator. There is no beach around them. And grassy areas have a show unchanged. It has the sand and the ridge. Now I will take a look at the show from the player's point of view. This little beach is okay. This one's too. I think that the sand texture is too bright. Let me swim a bit. Here's the underwater. MapMagick can generate it too. Unfortunately, I've got no shader for that. Now, when we are more or less happy with our beach, let's go further and create a grass. I will just select a flat valley for that. This one looks suitable. Now we'll create a grass generator. I'll make it in the bottom of the graph, under the textures. Create, output, grass. Grass output has the same layered structure as the texture generator. Clicking the plus button will add a layer, and clicking its name will expand its properties. I've assigned a texture, and since it looks like a sedge, I will rename this layer accordingly. As you can see, nothing has changed in the scene with adding a new layer. This is because nothing is assigned in a layer input slot. So we'll create a constant generator. Constant is a simple generator. All it does, it just fills all the map with a value inputted. I've filled everything with a value of 1. You can see that the grass appeared, but it looks weird yet, so I'll make some settings. Firstly, I'll switch the grass mode to the billboard. And then I will set its size. I know that I've got a rectangular billboard texture, so I will set a rectangular size. And then I will color it properly. I will not bother you with all the color adjustments. I've already got the presets needed. Now the grass looks much better, but it's still too loose. So I will increase its density. Now it seems to be okay. Then I will add the other grass type. It will be a sort of field flowers, so I'll call the layer chamomiles. Then I will assign a chamomiles texture. I want to make the flowers grow in small areas here and there, so I will use a noise generator for this. You can see that some of the chamomile polygons appeared, but it's not what I'm going to make yet. I will increase the noise contrast to the way we already made, by adjusting the bias and intensity. And then I will set up the layer. Oops, that's too big. I will adjust the noise a bit to make a field smaller. Now you may notice that the chamomile billboards are mixing with the sedge. Maybe it looks fine, but it doubles the grass density in the chamomile fields. To prevent this, use the obscure layers parameter. This will make the grass layers behave the same way as the texture output. All of the upper layers will dim the bottom ones. You may have noticed that the grass is spreading everywhere, including these cliff areas. To fix this, I will use a grass mask. I will take the texture output generator as a source. It has already got all the layers we need, and it's easy to find out what layers will be used for the mask. Obviously, cliffs and sand are not the proper layers to plant grass, so I will use grass and sediment layers. I will combine them both. And then take a look what we've got using preview. You can see that all of the cliffs are painted red, so the grass shouldn't grow there. So we'll connect this to the output using portal. I will name the portal grass. Seems that everything is almost okay, except one little detail. There are still some of the grass bushes on the cliffs. This happens because these cliffs have a grass texture blended with a low opacity. I will adjust the grass mask with a curve. Now it seems to be okay. There's one more thing I'd like to do with the grass. I'm going to plant the nettle at the hollow places. So I will create and set up the nettle layer. Nettle is a square texture, so I'm using the same white and height. To find the hollow areas I will need a cavity generator, and I should use a height map as a cavity source. So I will create a height portal, and then a cavity generator itself. I will connect the nettle input, but not to the convex output as we've already done, but to the concave one. Then I will rest the generator values to create the nettle, but it doesn't appear. So I'll take a look why, using the preview. It seems that I should go on raising the generator parameters. There's one thing I forgot about the nettle. It is switching it to the billboard mode. I don't really like it that way. It seems that I've got to use the curve to remove some of the nettle bushes at the center of the field. Let me preview the curve and set it up. I'll make it more contrast. It seems that the nettle is okay now. The next thing I'm going to do with the grass is removing its uniformity. You see there are endless planes of it, and I'm going to thin it out with some bold spots. I'll use noise generator for this. Now let me show you one interesting thing. I'll switch to the noise preview, and I will set the bias to 0.5 and intensity to 1. The noise will become homogeneous. I hope it will help me to explain. As many of the generators, the noise has two inputs. It is the main input and the mask. In case of the noise generator, these two inputs determine a noise blending type. The noise generator is applied additively to the input map. Here you can see that the grass has been added to our homogeneous noise. And to the mask input, the noise is applied multiplicative. You see it multiplies the green grass values with its 0.5 amount. And once again, input adds the noise, and mask multiplies with the noise. In this case, we need to use multiplication. So let us return to the bold spots. I will adjust the noise generator for them. It should have a relatively small size and a high contrast. And now let's take a closer look. It seems that we've got too many bold places, so I will adjust the noise bias. This seems to be okay. And now let's see what we finally got from the player's point of view. I think that the grass is okay for now. It's not too high, neither too low. Maybe the bold spots are too contrast, but I will adjust them later. So I think that it's enough of grass for now. And now let's add some stones. We will use the objects output to do that. Let's create the objects output, objects, and add the first prefab. I will assign the stone prefab there. You see, it's a usual prefab that could be placed in scene manually. Actually, it doesn't necessarily should be a stone, it can be any prefab, even an NPC or a mob creature. Then I will add scatter generator to scatter the stones. And when I connect the generators, you see nothing happens. And let me show you why. Let's get down, below the water level, down to the zero level of the scene. Here you can find the stones. Stone objects know nothing about the heatmap yet, so they are placed here. The count parameter of the scatter generator determines the quantity of the objects per terrain. The uniformity is how evenly are they distributed. I'm afraid it's hard to show it in such a case. Anyways, this parameter shouldn't be very large. Usually 0.1 is enough. And now let's position the stones on the land surface. We will use the floor generator for this. Let's connect it between the scatter and the objects output. And then I will connect a heatmap as a substrate map. I will use a portal. It is very convenient to have a fast access to the heatmap. Here you see, the stones are laying at the surface. But you probably may ask, why these stones are so small? They are almost not noticeable. The answer is rather simple. They are 1 meter in diameter. This was made to set the sizes and distances with the comfort, with no additional calculations. For example, if I want to set the size of the stone to 7 meters, I just set the scale to 7. So let's scale the stones. I will do this with an object adjust generator. Objects adjust. I will insert it between the scatter and the floor. You can see the 2 fields devoted to scale there. That's because we can set the range of the scales. Let's say we want the stone size to be 5 units minimum and 7 units maximum. You can see that all of the stones were scaled. Here the scale range is not very noticeable. But let me move the slider a bit. You can see that the minimum scale changes with the parameter change. Now you may notice that all of the stones are rotated at the same angle. To fix this, I will increase their maximum rotation, and increase it greatly. So when the rotation range is 360 degrees, all of the stones rotated randomly. Now you may notice that all of the stones are laying on the ground like a billiard balls. So let's plunge them a little into the ground. We will do this with the adjust generator, but the other one, that is placed after the floor. Because the floor generator will return the stones to the ground anyways. Here I will decrease the height a bit, at about the half of the meter. Maybe it's hard to notice the change, so we'll take a closer look at the stones. And now let me say a couple of words about the scale factor. Let me just diversify stone scale first. I turn back to the first adjust and decrease the minimum size. And then I'll take a closer look at these 2 stones with a different scale. When the scale factor is set to 0, the object size is not taken into account. All of the stones are lowered at the same height, both about 40 centimeters. But when I start to increase the factor, this 40 centimeter height is multiplied by the size of each stone. So at scale factor of 1, both of the stones are plunged at the same level of their mesh. Now I will diversify and adjust the stone's height. And then return the stone size. And even more, I'll make them a bit bigger. Now you may notice that some of the stones are attached to the cliff slopes. This doesn't look realistic, right? In such a case, the stones should fall down to the earth. So let's behave the nature should and slide the stones down. We will use the slide generator for that. I will insert it before the floor generator. Since the stones change their positions, they should be floored to the ground after. Then I will assign the height map as a slide map. Luckily, we already got a height portal nearby. You can see that the stones move down from the slopes. Let me increase the number of the iterations and see the whole picture. You can see that the stones are sliding down to the ocean. They even form a stone torrent sometimes. But, to be honest, we do not need such a huge slide amount. We just have to remove the stones from the slopes. So we'll set the number of iterations to 10 or maybe 15. And then I will stop the stones from sliding down if they are lying at non-inclined land. With a slope stop parameter, I can set what areas I evaluated as non-inclined in degrees. For example, setting it to 25 will stop the stones on the areas that are inclined 25 degrees or less. Here you can see the stones were sliding down from a steep cliff, but once they reached 25 degrees, they stopped. The other parameter worth mention is the move factor. It is the maximum distance the stone can travel per iteration. Decreasing this amount can help to avoid some bugs, especially when the surface is very detailed. But it will also require more iterations, and therefore more computing time. Then I will decrease the stones count and make some other adjustments. This should be fine. Now I'd like to make the stones a bit more scenic. Usually a single stone could be rarely found. There are some lesser stones nearby. So I'm going to create small stones around the big ones. I will make the smaller stones by copying the big. To copy them I will use the propagate generator. Traditionally I will insert it before the floor generator. You can see that each stone was doubled. That happened because the maximum count is set to 2 now. Let me adjust the count parameter. And now the distance. It determines how far the copied stones placed from the original point. And the scale factor, you're already familiar with it, but in this case I'd like to make a warning. Since the stone scale is set up to 10, the count and the distance are multiplied 10 times when the scale factor is set to 1. You see, it fills all of the terrain with stones, so you should be very careful with propagate scale factor, or you will create a million of objects at once. Now we'll lower the count and the distance values to create an adequate stones look. And since we need not the exact clones of the big stones, we are going to scale and rotate them. We will do this with an adjust generator. We are already familiar with it. But now we will reset all of the object transforms by switching relative mode to absolute. A relative adjust changed the previous parameters, while the absolute sets absolutely new transforms. You can see that all of the stones were set to small ones, because the scale value is equal to 1. I will increase it a bit. Then I will rotate the stones randomly by setting the rotation range from 0 to 360. It all looks great, but what about the big stones? They are gone since we started to use a propagate generator. It would be great if we could combine the previous unchanged big stones with the current small ones. And that's what the combine generator for. I will connect the first input to the small stones adjust generator, and the second input to the generator before the propagate. So the big stones were added to the small stone circles. Now I'd like to make some of the adjustments to the overall stones. First of all, I'd like to tidy up the graph. I don't like long connections, so I will split the portals in two. I will increase the playback speed to avoid wearing you out. This stone looks too small, so I will increase the minimum size. Now let's take a look from the play mode. The stones look rather similar, but that's not a surprise. We've used only one stone model, so that definitely should look similar. Okay, the stones are accepted. The next thing I'd like to add are trees. I will use the tree output generator to do that. Tree output is very similar to the object's output, except it doesn't create prefabs in scene, but it uses them as a terrain tree objects. So we'll create the first tree layer. You may notice an error in the console. It is not a magic error. It is a Unity terrain complains that the tree prototype has no prefab assigned. I will use a tree created in 3ds Max and prepared like a prefab. By the way, this prefab has no load levels to make Unity render it as a billboard in a distance. Now I'm making the usual setup. The scatter and then a floor. And once all of the generators are connected, the trees are created. For now they are placed everywhere, but I'm going to replace this setup with a forest generator. And then I will add an adjust generator to diversify the trees a bit. But when I try to scale the trees, the odd thing happens. Even if I will enable the tree scale, the tree sizes do not change. Actually, they do receive the scale information. You can see that their billboards are scaling. Here you can see better. And the most sad thing is that it is the original Unity bug that I cannot fix. Here, let me just draw some trees manually. You see I've got the full random size. Draw the trees and they are all the same. But when I will fly away to make them turn into billboards, you see that the billboards has got the scale information. Too bad, but the worst thing is that the same happens with the rotation. If the inability to scale the trees is rather bearable, then the absence of the rotation is really disappointing. This bug happens only with the trees that turn into billboards. The trees that have loads could be scaled and rotated. But let's get back to our forests. We have to use the different tree models for the different tree sizes anyways. The small pine couldn't be made just with a scaling. So let's add some more tree slots. Here we will assign a small tree, and here is the medium, and the big one is already assigned. Now our tree generator has got 3 inputs. But how to determine in which cases what input should be used? And that's what the split generator for. For instance, I will set the tree size range from 1 to 100. And then I will add the split generator. And add 3 layers. Each of them will have a name corresponding to the tree size. Small, medium, and tall, or maybe big. Then I will connect each of the split layers to the corresponding tree layer. You can see that all of the terrain became covered with small pines. This is because the split generator has a layered system turned on. If some of the layers have the same condition, the upper layer will be displayed. The alternative system to the layer is the random one. If some of the layers have the same conditions, then the final object is picked at random from all of the matching layers. And since the conditions for all of our tree layers are equal for now, then we can see that all of 3 tree types are appeared. And speaking about conditions, let's switch back to the layered mode. You can see that each layer has a set of ranges: height, rotation, and scale. The layer will be used only if the object height, rotation, and scale parameters lay within these ranges. Otherwise, the next layer will be used. So, let's try setting the small layer maximum scale to 20. You can see that in some cases, the small pines remain in scene. These are the objects that have a lesser scale than 20. But mostly they were replaced with the medium one, that have a scale range from 0 to 100. Let's limit the medium layer scale to 50. Now you see that all of 3 types with the different sizes are represented in the scene. Small pines are the ones who have a scale from 0 to 20, medium are those with a size from 20 to 50, let me write it down to illustrate, and big ones are from 50 to 100. For instance, let me limit the maximum scale to 60. You see, some of the pines are ignored. And you may probably ask what is chance parameter for. It just sets the chance of the object to be created when using the random mode. Now let me set up the tree ranges. And now I will replace randomly scattered trees with real forests. But firstly I will decrease the scatter number. These trees will be initial trees to grow a forest. And now I will remove the adjust generator. We will not need it anymore. And in the next step I will create a forest. It should be done before the floor generator. Then I will connect an initial trees as a seedlings input and output to the floor. You can see that the trees are now grouped together into a growth. Let me isolate the growths to make them more legible by decreasing the scatter count. And then let me select a particular growth, for example. To make the things obvious, I will start with the first year of the forest. Here you can see an initial seedling. Then I will start to increase the number of the years. Each year is one iteration of the generator. You can see a kind of time lapse of the forest growing. So when more than a century passed, forest became rather big. Now a couple of words about the generator values. The density parameter defines the maximum number of the trees in 100 square meters. If I will increase it, the trees are growing more tight. And if I will decrease it, the forest became loose. You can even see the sunspots in the gaps. Fecundity is a chance of the tree to produce the living sapling every year. Increasing this parameter will make the forest spread like a weeds, while decreasing it is more typical for the noble trees such as oaks. Seed distance is how far the sapling could be spawned from the tree. It seems that this effect is similar to fecundity, but it will differ when we will add a soil map. Larger seed distances can cross the areas with unsuitable soil and spread the forest further. Reproductive age is a tree age at which it starts to produce saplings. In this case, the tree is just growing 10 years, and at the 11th it starts to breed. It's better to change this parameter when the maximum age is changed. The survival rate determines the chance of the tree to reach the maximum age. When it is set to 1, the trees die only when they reach 100 years. This gives not enough space for the younger trees to grow in the center of the forest. So the center becomes very dense and filled with the old trees, while the younger ones grow only at the edge of the forest. And the maximum age parameter determines how long the tree can live. Note that increasing this value more than overall forest years doesn't make a sense. All of the trees will be younger than that maximum. And decreasing it can help to make all of the trees in the forests younger. And now I will prevent the trees from growing on the cliffs. I will do this by using the soil map. Actually, the soil map can contain more conditions than just the soil itself. For example, it can be blended with the slope to prevent the trees from growing on the slopes. But in this case I will just let the trees grow only on grass. I'll make a portal and select, as you may probably guessed, the grass map. Once it is connected, you can see that the forest is growing only on the grass textures. And now I will adjust the forest a bit. I will speed up the playback again. And once we are happy with the pine forests, I'd like to add the other forest type. It would be very odd if all of the trees will be represented by the one tree kind only. So I will add a birch forest. I will create an additional tree slots for the low, medium and tall birches and assign prefabs to them. And in the next steps I will almost repeat the forest we've just created. I will make the same generators with similar parameters and I will wire them accordingly. So a split generator with a small layer and range 0 to 5, medium with a range 5 to 20, and the big one with a range 20 to 100. Then connecting split layer to the output, creating a flow generator, a scatter generator with a count of 50. Please note that it should have the seed that is different from the pine scatter. And then the forest itself. The birch forests were created, but there is one issue with them. While the most of the forests look okay, there are some places where they intersect. The tree density is increased in such places and birches are often grow at the same position with the pines. So we'll include the pines into a birch forest calculations by assigning them as the other tree's input. This will stop the birches from spreading into the pine forests. Note that it is not necessary to do the vice versa and assign the birch output to the pine's other tree input. Actually, it will make the generate fail because of the infinite loop. If we want to assign the different forests to the one other tree's input, we should use the combined prior this input. And now let me show you the other forest's drawback. You see there's a pine growing through the stone. To fix it, we will use the subtree generator. This generator will remove all of the objects within some radius from the other objects. The minimum input is the objects whose count should be decreased. I'm assigning pines here. And the subtrahend input is the reference objects. They should be the stones. I will link them with a portal. Here we'll set the size factor to 1 to make the subtract distance depend from the stone size. Stone average diameter is 1, so the radius is 0.5. But since the stone is not perfectly round, I will add some margin and set 0.7. I will do the same for the birch forest. Now I will start the game and take a look how do the forests look in play mode. It seems that everything is okay, so we can move further. And now let me adjust the scene a bit. I will speed up the video again. I'm making the noise size and intensity smaller. And then I'm making the grass mask more contrast. And then the scene settings themselves. I will lower the sun a bit to make it look like an evening, and adjust its color and intensity. Then find some stunning place to set up the fog and the sky. I am rotating the skybox to make it match the light source direction. Then an evening color, it should be more of a yellow. And here is a spot that I don't like. I think that the sand texture is too bright here, so I'm replacing it with the pebbles. Then lowering the water level a bit. Then I wonder what happened with the fog. It seems that I forgot to turn it on in camera settings. Then adding the sun shafts effect. Now let's see how it looks from the player's position. Well, I'm pretty happy with the final picture. Now all of the generated terrains look fine, but what if we want to change some of the terrains? Create a town somewhere, a village, or any other key location. It is possible, but keep in mind that our global seed parameter and height map should not be changed from now on. First of all, I will unpin all of the terrains except two. I'm going to create village locations on them. Then I will find a place for the first village. And then place a village houses. I'm using the prefabs from the Unity's blacksmith demo. And I'm not going to make the village extra pretty, just a quick village sketch would be okay. And once I'm happy with the houses, I'm going to paint the roads. And then remove a grass from the roads. Now the village is ready, but any map magic generate will remove all of my roads and grass changes. To prevent this, I will use the lock feature. I select the map magic object, turn on the locking mode, and click on the terrain I've just modified. Now it is locked to any changes from the map magic side. Here, let me pin the neighbor terrain to show you that. I will wait a bit while it is generating. Now I will turn off the tree generator. You see, a pinned terrain has no trees left, while the locked one is unchanged. Or let me change the stone scatter seed. You see, they are changing only on the pinned terrain. But beware, changing the height map will make all of your land change, except the locked terrains. This will produce very noticeable borders. For example, I will change the Voronoi generator value. You see, there is a wall in the terrain. The land seems to be cut with a knife and then badly glued back. Well, increasing the height while distance can fix the situation a bit, but it's better to avoid changing the height so dramatically when you've got a locked terrain. So I'm undoing the change and unpinning the terrain. Now I'm going to create the second village. I'm locking the terrain and finding the best place for the village. This seems to be okay. I will create the second village the same way I've created the first one. I will make the small road into the woods, just for nothing. And then I'm going to create the third village. I'm pinning the terrain, and when it's generated, locking it. Then create the village itself. It seems to be the biggest village on an island, maybe because of its central position. And that's enough of the level design. Let's see the whole picture, and then start the play mode. You can see 3 locked terrains with red frames, and 3 blue frames of the generating terrains. But is it really okay if the pinned terrains are always displayed in a distance? We shouldn't see all of the village from any point of the land, and these terrains shouldn't take computing time. So it's better to have the far pinned terrains disabled and enable them only if they get within the generator range. And that's what hide far pinned feature for. I will turn it on and start the play mode again. You can see that the terrains were disabled. But wait, the village houses still remain. To make them change the active state with the terrains, they should be assigned as the terrain children in a hierarchy view. Let me show the hierarchy. I'm making the terrains parent to all of the objects that are placed on them. I'll start the play mode to see what has changed. You see the houses are disabled with the terrains. And now let's take a look what we finally created. So I'm starting the play mode and galloping to the first village. Pity these spines are so similar. I think that the only way to use the model tree is to prepare numerous prefabs with different rotations and place them in MapMagick using the random mode in the split generator. Okay, so here's the first village. You can see that all of the houses, land textures, modified grass, it all left unchanged. It's no surprise because it is the first terrain yet. Let's move to the other village. I should swim to get there. There's even an underwater exists. Unfortunately, I haven't set up the underwater shader. It could look interesting. I'll turn off the gravity to return to the surface. The distance between the villages doesn't seem to be very big in the scene view, but now you can see how far they are really located. Approaching the second village, so I'd rather walk than fly. The houses are still standing, and there is a path downhill. It looks nice, and it's really great that all of the scene was created just in an hour and a half. From the scratch, we had nothing when we started, not even a height map. Now it is fully textured terrain, with such an objects like trees and forests and stones. Now let's move to the third village. I'll turn the gravity off again, to get there in a straight and fast way. But sometimes I travel too fast. Terrains have no time to generate. This can be fixed by increasing the generate distance. It will make them to generate early before the player comes to their border. And here is the third village, somewhere in the center of the island. You can see that it's pretty far from the other two. So the goal is achieved. We've got a large island, about 100 square kilometers in size. Even only 2/3 of it are covered with the land. It is still twice bigger than the Skyrim territory. And it's mainly procedural landscape. It isn't saved anywhere and generating as the player approaches the terrain borders. The interesting thing is that the raw input can be tiled, so this island can repeat with the other Voronoi and noise parameters, so all of the lands can be filled with islands. This island has 3 key locations. They were made by taking the generated terrains and changing them manually in any way we wanted. I hope I didn't wear you out today. So experiment with the map magic, play with it is really fun, and create your worlds. Thank you for watching. Bye.